Hello, everyone. Thank you for coming to my talk. Today, I'll be talking about virtualization and my experience with both Harvester and Longhorn, which we're running in production back in Mauritius. So a bit about me. I'm Alex. I'm from Mauritius. I work as basically the Kubernetes person back home. There are my socials if you want to contact me after the conference. So some of my personal interests, Kubernetes, Linux, free and open source software, and I have a small home lab, which is about to become a lot bigger, in the living room. So, all right. My opinion is that containerization is the future. But you are probably going to go and tell me, what about my legacy VMs? To which I'd reply, you have to now run your VMs the cloud-native way. And you're probably going to call me insane. How, why, and yes, am I insane? You might also tell me that you like your virtualization stack, the existing one you have with all your legacy VMs running on it. No, you don't actually like your virtualization stack. It's just that you don't want to change. You don't want to make the effort to change your whole stack. But while you're happy with not changing, well, does management like the cost? Or at least, do you even like the fact you have to add an extra zero to the budget every year? How easy is your exit plan? I mean, we're talking about digital sovereignty a lot these days, end of 10. So given that a lot of the virtualization stacks out there are proprietary, closed source, it becomes a lot harder for you to plan, well, how am I going to get out in case something happens with some foreign government which might impact my production services presently? And yeah, is it even open source? I like open source. So in comes Harvester. And what is Harvester? It's a platform for what we call hyperconverged infrastructure. But other than that, it's a collection of open source software. It's not itself a certain program, but rather a collection of a whole load of cloud-native tools and technologies. And it's your cloud on-prem solution. So rather than going to pay cloud service providers a ton of money, you can have the same level of features and facilities on-prem with servers that you own. And Harvester is the free version of SUSE virtualization. Hyperconverged what? So hyperconverged infrastructure, it means that everything infrastructure related is all under one roof. Infrastructure itself can be decomposed into 3 broad categories. So you've got compute, which runs your applications, storage for all your data, databases, etc., and then the networking side of things. Why is it good to have all of this infrastructure under one roof? Well, for starters, you have one interface, which makes managing everything compute, networking, and storage much simpler. You can specialize in one technology stack rather than 3 different tech stacks, which might also be from different vendors. You have much tighter integration of those 3 components. And you can have everything in one nice UI rather than 3 maybe ugly ones. So this is part of the Harvester UI, which I'll show a bit more of later. And it shows all the components which you are able to manage. So hosts, which are like your physical servers, the VMs, you've got volumes for your data, images for your operating system, like you put your ISOs there. You can even separate all your all your VMs and containers even into different projects or namespaces. Networking, there's a whole load of options for networking. I'm myself not really a networking person. Of course, you need backups and snapshots, which leverage Longhorn behind. Monitoring and logging, very important. RBAC, if you've got many people all using your Harvester installation. And then some more advanced features, which are a bit more low-level into the tech stack which Harvester uses. So I've said that Harvester is a collection of technologies. But what is it exactly? At the base, you've got RK2. Rancher Kubernetes Engine 2. It's a Kubernetes distribution. You've got many out there. You've got things like K3s, K0s, vanilla Kubernetes itself. It's fully compliant with vanilla Kubernetes, but has some extra security-oriented features. and has the ability to be licensed and supported by SUSE. It's compliant with many CIS benchmarks out of the box, and you can easily make it a lot more secure or harden it to a much greater extent using just a single flag in your Harvester installation. Then on top of that, you've got KubeVirt. So for those who aren't familiar, KubeVirt, it's an incubating CNCF project. The CNCF is a cloud-native computing foundation, and you can go to landscape.cncf.io to see a whole list of projects, KubeVirt one of them. Obviously, open source. And it allows you to run virtual machines directly on top of Kubernetes clusters through KVM. Longhorn, because of course you've got your compute, but now you need storage to go along with it. This also is a CNCF project, incubating, once again open source. And it provides persistent storage to what would otherwise be a stateless cluster. You have the ability to create replicas of volumes. So if I have maybe one server which has a disk attached, that disk's volume can be replicated across all of my host physical servers, which gives me a great layer of redundancy. So that means one of my nodes could go down, and given that the data is replicated, the VM could easily just be shifted to another machine and keep on running without any issues or downtime. Harvester also comes prepackaged with Prometheus and Grafana. They are built in for monitoring purposes, everything you want to do with relating to metrics. You can also do alerts. The integrated Grafana dashboard lets you monitor the state of both your host nodes and all the VMs which can be running on top of it. And finally, to bring everything together, you've got Rancher, which is the UI to manage the entire cluster. It makes it easy to manage everything in one place. And for people who aren't as, I would say, console-oriented, it's got plenty of buttons and places you can click to achieve the same features. So let's talk a quick bit about the compute. So I mentioned that Harvester is built on top of Kubernetes, which means that it is meant to be clustered. You're not going to have a single node. Of course, you could have a single node, but for production, you can have it clustered, 3 or more servers for high availability, redundancy in case any of your servers goes down. Also gives you a lot more freedom for upgrades and things like that without actually impacting your users. Seamless failover, server failure, of course. And VMs are going to all run through KubeVirt, and storage is managed like under the hood. You don't have to really interact with it through Longhorn. And because it is Kubernetes, that means you're able to run all your containers in parallel with your VM workloads. So from my perspective, and the way I started my presentation, you're able to have both the past, so your legacy Windows 10 VMs, and the future of infrastructure, that is containers, all in one platform. So this is production back home. We've got 3 nodes. So you can see a bit about, like, give CPU metrics, memory, some storage, IP, disk state. And from here, you can also put your nodes into maintenance mode, which will evict all your volumes, evict all your workloads, which gives you the freedom to, go into that node, maybe upgrade it if you need, or manipulate it in other ways. So this is VMs. These are also VMs running on the production cluster, but this is my playground. I've got a few VMs running here. You can access them through a console. So even through your web, even if you don't have a VPN back to the office, you can access the console through WebVNC or Serial Console through your browser itself, which is it's a neat tool to have. You can also see here, for example, the CPUs have allocated, RAM, the IP addresses has been allocated, and also which which host the VM is actually running on. Of course, you can go into any of these, configure it, add disks, remove disks, any kind of manipulation like that. Networking, which is not my favorite topic. You're able to create networks within Harvester for your different VMs. So as you must have noticed here, the different VMs have got different IPs. Some of them are 10.5.106, and another one is 10.03 dot something. So you're able to create these different networks and even integrate maybe your existing VLANs with Harvester for your different VM needs. You can also have, well, you can also integrate more physical networking side of things for your different VMs. So maybe you have this super critical virtual machine set of VMs, this project, and you can't, at any cost, have any downtime to it. You might have some special infrastructure needs. It might even need more than just 1 gigabit Ethernet, so you could connect your fiber cable to it. And you can reserve different ports for different networks within Harvester, and then allocate these networks to your VMs afterwards. You also have the ability to separate your data control for the Kubernetes Kube API and the network for storage. Because after all, Longhorn is doing that whole redundancy business, which means that it is replicating your data in real time to different volumes. So if you need, you can have a specific cable, switch, router, whatever, for your, just to manage your storage. So this is the networking UI. Of course, you have some cluster network configuration and then VM networks, which let you specify, for example, your IP range and things like that. But something actually which I found very interesting is that it gives you load balancers directly in Harvester. So you can allocate IPs, and then the underlying Kubernetes thing will all take care of listening to those IPs and then redirecting it to your VMs as needed. So storage with Longhorn. So as I mentioned, Harvester uses Longhorn, which is a CNCF project for storage. It's open source, cloud native, and is a persistent block storage solution. Data is replicated, so you have redundancy and high availability. And also, Longhorn has easy integration with both S3 and NFS for all your backup needs. A really cool feature, actually, which I haven't included in the slides, is that with Longhorn, you're able to take snapshots of your volumes and thus your VMs. And these snapshots, it's instantaneous. In 1 second, you can have a snapshot of your VM at a certain point in time. You don't need to wait for a lengthy backup, just a snapshot if you're going to maybe, I don't know, do something a bit risky to your database server. Snapshot it before. If you made a mistake, just roll back. It's really simple, really fast, and really easy to do. So this is a bit of the underlying technology behind Longhorn. So you'll have your Kubernetes volumes, which are then consumed by the virtual machines running on top, which interacts then with the Longhorn engine. Longhorn engine then takes care of all the replicas. So in this case, you can see for one volume, it's doing only 2 replicas, and these replicas are put onto different disks on different nodes. Longhorn UI, it's a very nice UI. You don't even need to actually interact with this UI in a day-to-day use. I'm just showing it here because it's cool when you're maybe pushing your cluster to the limits. You might need access to the Longhorn UI directly to unlock some features which Harvester doesn't yet expose to the user. So here you can see volumes. I've got so much storage, which is schedulable or in use, my 3 nodes and things like that. If you want to go into one volume in particular, you can have a lot of details. The volume details on the left here is really long. You can see everything about it, where that persistent volume is mounted, what VMs are using it, what host is it on, and everything like that. And in my case, I've only got 2 replicas. So you can see that one replica is on Harvester 1 and the other replica on Harvester 2. And you can see also that I have snapshot schedule, actually, which runs more or less every day or whenever I need. So this is Harvester in a nutshell. At the bottom, you've got your nodes with the compute and the storage. On top of that, you've got RKE2. On top of RKE2, you've got Longhorn, which also gives you direct access to storage underlying Harvester. On top of this, you can either have your container workloads directly, the same way you would interact with Kubernetes, vanilla Kubernetes. Or otherwise, you can go the KubeVirt route and then have your VM workloads sitting on top of KubeVirt. So yeah, that's Harvester in a nutshell. I hope that's been interesting. Maybe you'll be tempted to paint your VM infrastructure green next time. So of course, these are my socials, and my slides are on my GitHub over here in case anyone wants to check them out. So any questions?
You mentioned having S3 integration.
Yes.
And full disclosure, I work at Amazon, so this is like something that's obviously interesting to me. Have you looked at the ability to do any kind of direct API with the EBS volumes to create snapshots that were consistent?
No, I'm going to admit I haven't gone in that depth, obviously, with Harvester yet. I am tempted to create a Harvester test cluster, which I can break to my pleasure.
Let's talk about that later.
Sorry?
We'll talk about that later.
Absolutely, I'd be happy to. Of course, in my case, I've been using Harvester in production, so I haven't pushed it to the same limits, obviously, that I would have pushed my home lab to. So, yeah. Any other questions? No other questions? So I take it then that everyone is going to go, when they get back home, they're going to just go and replace VMware or whatever existing stuff they have with Harvester. Cool. Thank you very much.